to have much higher capacity in the network and then bring that capacity to where it's needed at each time, either from a location or a user basis, and allow us to grow to the capacity needs of 5G. Finally, on the right-hand side, we talked a little bit about the need for different architectures. We see this all going all the way to having an entire network in a box at some point if we need to have a deployment, say, for a particularly mission-critical application that requires control, latency, and so forth all in the same place. And then across the bottom, we have a few other areas, or I think important characteristics that will be managed all the way through this. RF densification will continue. So I think, again, this is the main subject of a lot of people in this room in your everyday business. It'll become more and more important as we start mixing different types of technologies more intimately in the network. Distributed clouds, of course, is another key technology to provide this flexible bandwidth. And then finally, multi-cell coordination. As we start looking at high frequencies, low cell site distances, and overlapping networks of different technologies, macro and small cell networks, the ability of the network to manage itself across those boundaries is going to be very critical. We also see, we talked about everything going into a box in some cases. We really see everything going into a cloud as well. We're looking at a cloud, really cloud architecture changes us from a hardware game to more of a software game. We'll have software-defined networks that really allow all kinds of new ways of managing the network. The cloud will handle automation and authentication and administration within that cloud. And we're starting to have more automation as to how we add and remove applications, add and remove services in the network. This will allow, through orchestration, through software-defined networks, give us the flexibility to roll out new kinds of services using network slices where we can offer certain pieces of the network to users for certain functions, as well as service chaining where we can bring the whole network to bear. Another critical part of this, which I'll talk about, I think, on the next slide, is analytics. We're going to be talking about a very large and flexible network. It'll be important that we pull the right data out of this network and have the right analysis so that we can then consistently manage this network and maximize its capacity. Finally, I think a key point as we look at the complexity here is systems integration. And tools like SON are going to be increasingly important to roll out the different numbers of network elements, different types of network elements smoothly. And a little bit on data. All the operators know they're sitting on an awful lot of data today, and we're starting to see some initiatives to mine some of that data. A lot of the data is customer information. How do we appropriately and effectively mine that data to learn more about our customers and to get insight into what's driving our customers' behavior? Essentially, we want to get all the way to at the bottom, which is essentially a customer digital footprint. How do we understand the customer and their environment and help with targeted advertising in a non-intrusive way, help with targeting much better, and help really use that to have a better understanding of the competitive environment we're facing with our markets. We also see another key application for this data, which is to help manage the network. We're starting to do some work today in what we call predictive operations, where we're able to look at the performance of the network and basically look at triggers and levels of performance and identify problems even before they affect the network and take action at that point in time. So let's maybe recap a little bit of some of the operator challenges that we're seeing. Exponential traffic growth driven by behavior we're seeing today, as well as this explosion to billions of connected devices. Low latency requirements, as we have to have new architectures to support new kinds of applications, new kinds of devices in the network. Complexity, we'll manage through software-defined networks and really advanced tools like SON. And then basically scalable performance remains extremely critical. But I think the box in the lower middle is probably the one that comes to heart for most of the people in this room, which is how do we effectively deploy these networks? We're going to be putting more and more sites more and more closely together. As we heard earlier, there's some regulatory issues that need to be addressed to smooth this process. But we're also doing a lot of work in the industry to make this a more straightforward process. One of the things I wanted to talk about, and we included a USB stick in your welcome bag. With Nokia and SAC Wireless, we've developed an initiative we're calling the HetNet Engine Room, or HER, where we have an innovative process where we combine site acquisition and design aspects, and we can basically look at the process of identifying and qualifying sites without having to go out to those sites or without having to leave the office. We're looking at mapping data to evaluate sites. We're looking at databases of power and backhaul capabilities, coupled with RF design to evaluate effectiveness. So I think we have a video we run on that in the USB, which I think you'll find very interesting, and we can talk about it if you want to have some side conversations today. So let's talk then about some of the other things we see that we have to build capabilities to build for this level of the future. So network planning and optimization has been a key part of building networks all along. We see it becoming more and more critical. as we go to lower and lower frequencies, more and more cells, and in fact overlapping technologies with different characteristics, it's going to be important to very efficiently do this design. So we and others in the industry are investing in things like 3D planning, where we can look at not just planning on the plane, but look at planning and distribution of traffic vertically as well. We're looking at more automated tools. We're looking at better use of SON for self-organizing and self-optimizing networks, as well as different forms of driverless optimization where we can optimize the network much more cost effectively. So I think we'll see a lot more investments in this area and really help to optimize the operator's expense in these areas. Site acquisition, we talked about with HetNet Engine Room. Site acquisition and construction, again, I think it's the top of mind issue for a lot of you. We've got to drive the costs down. I think some regulatory barriers are important as well, but also more efficient processes so that we can look at the mass number of sites that we need to build an effective, dense network. Construction is going to be important as well. We have to look at how we can optimize, make products easier to install, and how can we take shortcuts in terms of minimizing cost. One of the areas I know a number of people are looking at is the use of drones for site inspections or site surveys, so we don't have to climb the tower in all cases. I think a lot of very exciting things developing there. Next one is network operations, and more on the back end once we have the network running. This is where we see things like the use of data for predictive operations as being very key. How do we more effectively manage this very complicated network, but also what's most important to the operator is their customer satisfaction. Let's identify the problems before it causes a problem for the customer and fix it before we even know something's going on. And ultimately, we want to drive this to self-healing networks. We don't even have to necessarily interfere. So we've talked about a number of things, and starting with the vision of us going from around 5 billion users today with discrete devices to 50 billion interconnected things. It's the Internet of Things, it's new applications, it's just really a big frontier for us. And some of the investments that we're making and the industry's making in the automation, the virtualization, standardization, and intelligent operations we'll need to build these networks. I think it's a very exciting future. I think one key point is none of us are going to get there alone. I think it's going to take a partnership of capabilities from different companies to really bring about this vision. And if you look at some of the words we have on the box on the left, proactive, aware, responsive, and optimized, some of these are a little familiar. I think some of it's also pushing the envelope a little bit in terms of how we need to manage and run networks in the future. So I wanted to thank you for joining me today. Again, take a look at the video we have in the USB. I don't know, John, if we have a couple minutes for questions, I can entertain a few questions. Maybe just open it up for a little discussion before the next speaker. Yes?
So how long do you think it'll be before we actually see 5G begin to materialize technologically? I know we have all the bits and pieces, but there are different paths right now to explore.
Yep. So I think standardization is clearly one path. Frequencies are another path. I think some of it will be more of an evolution, but I don't really have a good exact crystal ball in terms of when new bands will come online. I know we're starting trials with a number of major customers now, or very shortly. They'll start looking at some of the key technology elements. So I don't have a specific crystal ball on timing. We're kind of looking at a 2025 timeframe when we see the world is somewhat different. Exactly what the steps are and everything, I think we still have some variables we need to look at to get there. Yeah. Yes.
Talk a little bit to how Nokia is developing products for the purposes of making development and deployment easier. How products can be made to bypass some of the regulatory issues that you just spoke of.
Yeah, I think footprint's one, right? If we can identify, and what Don asked was, what can be done to, and what are we doing to try to bypass some of the issues in terms of product deployment? I think footprint is one. If we can take advantage of any rulings that would limit the amount of approval that needs to be made for certain footprinted devices, clearly staying within that is important. I think another key area is building self-integrating and self-configuring capabilities into products. Well, we need to do a physical installation, we need to do some connectivity, but we'd like to be able to make sure that most of the commissioning and integration and parameter setting is either automatic or certainly remotable. Tools like SON, I think, help us with that as well because it gives us some more automation in some of the design phases in the network. Okay, thanks, Don. Any other quick questions? Okay, thank you.